You're welcome, warmly welcome in our community, and biggest thanks for joining at the end of the year. It's super busy time, but you find the time for us. Biggest thanks that you help grow up our community. You're welcome.
Thank you, Anna. Thanks for the amazing introduction that you gave me. And hello, everyone. This is Supratim here. So quickly, I'll just share my screen and I'll just let me know if it's visible once I share my screen. Wait, there's some. I guess it is. Yeah.
For now, it's your caution.
Oh, yeah. Yeah.
No, it's
Sure.
okay.
I'll
We're
just.
waiting for your slides.
Yeah. I'll just jump into my slides and here it is.
Slide
Switch to
is
full screen.
visible, voice is perfect. So, okay, let's start.
Okay, so let's start. So, hi, this is Supratim Dhara. I'm from India and I'm working as a founding engineer at Pegman India, which is a startup based out of Kolkata on the eastern part of India. And today we'll be talking about scalable Flutter apps with clean architecture. So, architecture, this is a vast topic to talk on. Like, it's a big thing in any application, be it mobile, be it any desktop apps, be it Mac OS, anything. So, an app, the performance and the capabilities of an app or a software is very dependent on the architecture that it follows. So we'll be talking about clean architecture in this one. And so the agenda for today would be very simple. The first thing is the problem of scaling apps. So many companies and many apps, those have a particular architecture thought of and planned out at the first of the, like, when the app is being built, and then they have to switch over to another architecture or any other form of architecture. So this comes when you have to scale your apps to a larger audience. Let's say you are building an app for 500 people, then you see that your app has become quite popular among the masses and it's serving almost, let's say, 10,000 or a million users at the moment. So you have got to scale your app, and then you need to change your architecture. There are a lot of problems that are faced during this process. So then we'll that would we would be the first point or problem statement for the agenda. Today's session. Then there is clean architecture. What does clean architecture means? Uh, as there are many types of architecture, like clean architecture, there is MVVM, which stands for model view model. There is MVC, which is a model view controller. So clean architecture, I feel like it's the easiest and the easiest to implement architecture. So next up, after that, we'll be going over to implementing clean architecture in Flutter. So an app, it has to be in which is built in Flutter. How we can implement clean architecture in that, and then I'll leave the stage for you guys. I mean, not you guys. I would open my stage to you guys to question me, and I would like to answer any of the questions. So next up is the problem with scaling apps. So scalability is a big issue when your architecture is not the right one, uh, for the that is not right for the app. So an architecture is decided mostly on few factors. Some of them are the number of people that the app is going to serve, or number of people or the number of users that are estimated or approximated for the app to be used by. The second one is the size of the application, the number of screens that it contains, the number of user flows it contains, and the complexity of the app. The third thing that should be considered but is not considered is this type of data that it carries or it takes in from the user. A lot of architectures focuses on the safety of data, or a lot of architecture doesn't. So there are you there these are like, whenever you are dealing with sensitive data, be it user data, be it passwords, be it anything, user data are mostly very sensitive data. So you should be very clear and very proficient with architecture, architecting your app, and like you should be I mean, designing the app architecture from the first only. So yeah, so here you can see this is an meme which says huge app in production, you pushed your code to a production, your app is live, and you later realize that you have unsolved bugs, you have messy code, you have improper architecture. These are the three pillars that is like holding up the app that is in production as and is almost at the edge to fall down. So here it says the hidden cost of messy architecture, that is, do you know that 75% of app maintenance costs stem from poor architecture choices. So app maintenance, once you upload an app to the app store or play store or anything, whatever the platform you are working on, let's say you are working on an app that is going to get pushed to mac os or mac os specific or ios or android, then whatever the app is pushed on the platform, but it doesn't always mean that you don't have to spend a huge amount of money on the app maintenance, because dockerization, containerization, all of these things are very dependent on how you structure your app. So messy architecture means you have messy code. One is messy code, no comments, no proper structuring, no UI layer, no business logic layer. So there is a whole mess of things. All of the functions are like scattered here and there, and all of the functions or all of the initializations are happening on the same file, and everything like it's a mess. It's a mess. There is unsolved bugs. There are like you create logs and you push it to production, but you have a lot of files of logs that I mean bugs or issues that are unsolved. So still you push the app to production as your architecture lets you not address them at the right moment. And then there is improper architecture that we have been talking about for a moment. So here
Thank you,
uh,
Supratim. I'm so sorry that I disturb you. I think your presentation is not visible.
um, is it now?
Can you please try to share one more time? No, it's not visible.
Let me just try it once
Mhm.
again. I don't know. Wait. Is it visible right now? Like, uh,
Recursion. For now, it's recursion. And
okay, good, good, good.
let's open
I
your
guess there was some glitch with the like.
super.
Uh,
Thank
is it
you.
now? Yeah.
Yes, perfect. Thank you.
Okay. So here it says that it's whatever I said. This is the thing. Like here a study also says that 500 plus app failures was caused by structural issues. So the structure of your app, the architecture of your app causes a lot of crashes, a lot of user data leaks, user data hampers. Everything can happen due to architecture. So see how I apps fail to scale. So you might have seen that your app is being built and pushed into production, and then your manager comes up and says that, hey, we need to scale up this app for a million users in the next few months. And you say, okay, we can do it, but we need more amount of time for us. But we don't consider the like we as developers, we don't consider the time that it would take for us when the app is very long or the code base is huge. As as the code base grows in size, in number of lines, in number of functions, in number of methods that is being called, and in number of services it uses, the ease of scaling also grows at double rates. As you can see from this graph, this is a very arbitrary graph and this I have drawn myself. So here the darker blue line shows that the code growth, when the code is very small, it's very easy for anyone to scale the app with the help of a proper architecture. So here it says without proper organization, which also means architecture, scaling becomes impractical. It is what it is. Like you cannot scale an app which is not properly uh, like organized, or the architecture is not organized. So problems include a duplication of logic. Yes, we as Flutter developers or any developer, if we do not duplicate, we tend to duplicate the logic and code for the logic. So if you are using one button in 10 different screens, then you have to and then you have to scale it up to 100 screens. So whenever you are duplicating the first one, then you have to copy it on the other 10 screens as well. Then there is tightly coupled components, there are nested components, there are nested widgets which we use, and hard to maintain as the app grows. Yes, it does, as I explained that it does. It is very important to formulate your architecture at the very beginning. So what is clean architecture? We have been talking about architecture. I've been speaking about architecture. So let's go ahead and see what clean architecture or the easiest architecture that we can think of. So clean architecture is divided into three layers, clear layers. For clean architecture is very simple to implement, and it is beyond the code quality that you get. It is beyond, it is very organized, so you can easily refactor the code, you can reuse the code. So three layers consist of presentation layer, the domain layer, and the data layer. So data presentation layer is purely deals with the UI of the app. So presentation layer consists of mostly the screens that you design, the widgets that you reuse or you build for each screen, and the whole UI of the app, be it XYZ number, n number of widgets or n number of screens. Everything stays in the presentation layer. Then comes the domain layer, the core business logic, the app that we're building, the business logic. Let's say if you're building a Uber, like Uber clone, then you should be having the UI layer in the presentation layer, and the business logic, that is the cab booking, the parcel booking, or whatever the services are, that is the core business of Uber, that should stay in the domain layer. And then there is the data layer. So data layer, it handles API calls and data models and many other things, services, there are requests, other things. So API calls, data models, these are everything that, as the name suggests, data. Every day, all the data thing, that is the user data, the API, the network calls, all these is stored in this, I mean the data layer. And this formulates the clean architecture. Okay, so next slide is, okay, this is a very important slide, as you guys must be knowing that Google Pay, which is a big app that has recently transformed into Flutter. So it is completely built on Flutter, though the UI part and everything. So if we take that example of Google Pay and if we put that into clean architecture, let's see how it is built, like Google Pay, how it is built. So Google Pay, being a scalable app handling large scale transaction, likely follows clean architecture principle to ensure scalability, flexibility, and smooth integration. As you know, Google Pay is very integrative, and smooth integration of it through on various platforms as well. So first, on this, this circle thing, like the Venn diagram that I've prepared, is the UI layer. So all the UI stuff, from Google Pay transaction screens to the home screen to the your profile screen, everything is stored in this layer, the UI layer. So Flutter UI for seamless user integration, example balance, transactions, everything. And then there comes is the domain layer. So the layer under this is the domain layer. Domain layer consists of the core business logic or core business principles, like payment processing, transaction validation, payment validation, then user authentication, and other things. All these things that are core business logic or core business ideas, what Google Pay serves for, how Google Pay makes money, is the domain layer. Okay, if you can crack into the domain layer of any app, you can get how that app or that company makes money. So next up is the data layer, manages local data and in API integrations. So it local data means you are storing your passwords, your bank passwords, your bank credit card or debit card numbers. You are storing your location or cash data or some sort of profile picture or anything. I don't think that Google Pay supports profile picture. I might be mistaken, but I take that back. But anything that is locally stored for the user, or any API integration, be it for payments, be it for transaction, be it for account statements, be it for balance informations, all this is data layer. This is a layer beyond that comes after domain layer. And last and the most important layer is integration layer, connects third party services like payment processors or Firebase. Firebase is just an example. I guess at large scale apps, Firebase is not that efficient, or I shouldn't comment on this because Firebase is a very efficient service. But here is the just an example of Firebase. So the third party services like payment processors means there are other payment platforms that which supports like Google Pay to get payments and take payments from. So integration layer is the layer that connects all of this or uses all of this to form the Google Pay app. So let's take an example that your friend who lives in 30 kilometers away from you sends you money. So you get the money on Google Pay, and you how this travels. So that person, let's assume that person is X. Okay, here's a person and you are Y. So X sends 100 to Y. So whenever X sends $100, the integration layer catches that through payment processors. So how does it catch it? Let's say that person uses Razorpay or let's say Stripe. Razorpay is exclusive to India. I shouldn't take that example. So Stripe, they use Stripe to integrate to Google Pay and they send it to you. Why? And integration layer connects that Stripe payment to you, and then an API call is made when you fetch the payments, like whatever the payment history or the transaction history was. So it comes onto the data layer, and then whenever you are like uh, connecting with the API or the Google API for your payments, it is fetching the data from all these third party services, the bank API, and the local data that is stored in it. So all of that information is passed on to domain layer, which is responsible for transaction validation and payment processing. Let's say there are 10 payments in which the ninth or the eighth payment is your friends who sent you $100. So the domain layer would contain the logic to verify all those 10 payments and would uh, like uh, verify all those 10 payments and would tell which one is a valid transaction and which one was not. That's where we see that there are many transactions, those are cancelled or those have been paused, or maybe your bank balance was zero but you tried to send $200 to your friend, then it got cancelled, etc. So this domain layer would contain the data for all those things that the transaction was, then all the the information from integration layer, from data layer, and then comes the UI layer that we as users see. We just hit a button or click a button on our mobile devices, and we see that, yeah, I got $100 from this friend, and okay, I sent him $200. So UI layer, how it functions is, it takes all the information from all these layers and reflect it to you on the screen. Like every other layer is connected to one another. This is what I meant. So yes, now comes the elephant in the room, that is implementing clean architecture in Flutter apps. I should have written Flutter apps. Why I didn't write Flutter apps is because architecture is meant for all kinds of software. Before we all developers, we make a mistake that I have pointed out. That is, we say I am a Flutter developer, I am a Android developer, I am a Angular developer, but we all are software developers. So architecture is meant for all kinds of software. It is not constrained to any SDK, any platform, any tool, or anything. So Flutter as a whole, like SDK, supports clean architecture. So this is what I meant, that implementing clean architecture in Flutter. So let's see how we do it. So first thing, modular Flutter app structure. So Flutter app structure, if you are if you are like implementing um uh, clean architecture on Flutter, this is how your basic app, like app structure would look. That is, the first layer is the presentation layer, that consists of UI layer, that is purely based on UIs. Okay, so as it says, widgets and screens. Then there is domain layer, that serves the business logic layer. I mean, all the business logic stores in, it's stored in this. And there is data layer. Then there is a models, network calls, logs, error handlers, exception handlers, everything. And there is core component. Core component here, I would say, like core component is not necessary for all apps, but is very essential for most of the apps. So utils, constants, firebase options, or you are integrating a app, right, a superbase, or anything, any third party services. So all of that information with those APIs for like all the third parties APIs, those are stored in folder. Next up comes is example of state management. So state management, like, is a very big chapter. I won't go into it because it would take the whole session or else. So state management is essentially carrying on the value and the state of the same thing to another screen. So from screen 1 you are carrying the value and the state to another screen, screen 2. This is the whole thing that is there in state management. So first up is state model. As you know, models are like we pass on the model to change notifiers. So change notifiers are like, these are functions or constructors that that would take the value from one screen to another. How it does, it takes a notifier from the first screen and passes on to the second screen. So if you have seen the boilerplate code or the vanilla app that we see for Flutter, there is a counting mechanism that takes in the number of taps that you did on the plus icon. So this is how it looks like, the class counter with change notifier. Okay, so this counter thing, this, if we consider that app as the app implemented with clean architecture, change notifier with counter would be the business logic in it, because that's how that is the point where the main logic of the app is stored. So this would be staying in domain layer. Next is the consumer widget. So consumer widget is the widget that is uh, that renders UI or the state change that happens in the previous screen. So consumer, what it does is takes the number of counts that you have did on the first screen, and when it is passed on to the second screen, a consumer widget comes into the picture and renders the number of count that you have, a number of times you have pressed, that is stored in the counter widget, a counter variable, and renders the UI according to the value of the counter. Next is the third thing is the provider, which is a change notifier provider to inject and share the state across all widgets. So provider, as the name suggests, it takes in the change notifier value and like pushes on to all the places where this value of count is being used. So these are three like very basic things that I can show you with clean architecture, or these are like, this is the UI layer, consumer widget, this is a UI layer, so it would stay in the presentation layer. Then this change notifier is the business logic, so it would be staying in domain layer. And this provider, this is a sort of API call which is happening natively or local data passage bridge, we can say. So it would be staying in the data layer. So next up is the API handling that I was talking about. So API handling is the big chunk of data that we get from APIs, and we store all of the API thing in the data layer. So fetch data, this is a very simple get request that we are fetching. This is a example URI, or this is the thing, like the fetch data or fetch data function. This is the async function that is responsible for getting the data from the API. So if you take that Google Pay example, so when you are calling the data, we are getting the API data from a server that is stored anywhere in the world, and that is used, that is passed on to the UI layer through the domain layer by verifying the transactions and all of this, all of those things. So I'll, if we consider that fetch data function, then that fetch data function would be stored in the data layer as it's a network call that is happening. And then comes is the future builder, which handles asynchronous data and also renders the UI that is being like if it's a loading state, if it's a error state. So it's a mix of both data layer and the presentation layer. So here you can see that here are two of these things, like there is a circular progress indicator which has a two kinds of thing, like if it's an error, or if it's a like has errors, or it doesn't has error. So future builder is taking the data from fetch user, which is which was pulling out pulling the data from the API. So as I said, when the data is passed on through the circles of clean architecture, then this happens. Like future builder is dependent on the previous layer, that is the data layer. So fetch user data is a function that provides the data to future builder, which is on the next layer, that is the UI layer. So data layer, from where the API calls are being made, it passes on to the domain layer, which verifies the data if the transaction is valid, if your everything is valid. Then some things happen there, we can don't talk about it, and then we pass on that data to the UI layer, that is the future builder function, where it verifies the fetch user data, the user data that we got from the API that we fetched. It verifies for errors, it verifies for if there are no errors, if there are errors, or uh, the data is completely not there. So snapshot is some, like the snapshot is the, as we get the JSON map, there is a snapshot of um, that JSON map image. So we get that, and we show the error if it is there. If it's not there, we just render the thing, like render the whatever the output is. So yeah, that was about the whole clean architecture thing. And yes, I guess I wrapped up too fast. I went on and talked about all of these things. So here is my link to the socials that I am, and that was it from me. And happy new year in advance, and a belated merry Christmas to all. And if you have any questions, you can drop it down on the chat box, or you can connect with me and we can chat about it as well. So I'll just quickly down to the other screen, like where the chat bot is, I mean chat box is. So I